Artificial intelligence in music are often associated with emotionless algorithms, automated processes, and the loss of artistic identity. Our Eurorack module, or BRAIN, named after the small artificial neural network inside, follows a different approach. The small AI listens, learns, and tries to reproduce what it heard. In doing so, it stumbles, chirps, and rustles, gets lost in chaos, and suddenly recognizes patterns. This is anything but perfect. It is a constant search for new ways, and that is alive in a certain way. Welcome to our demo video of the BRAIN module. The neural network inside our module makes it possible to experiment with machine learning algorithms in the realm of Eurorack synthesizers. Let's now look at how the module works with a small example. Let's imagine we want the module to learn a melody. Our melody has 8 steps, and these 8 steps are continuously played by a sequencer in a loop. We see the control voltage for the pitch here as a blue line on the oscilloscope. This control voltage is also fed through the blue cable into the input jack YN. Well, a melody is a time-based thing. This means the neural network must also have information about each particular point in time. Our solution is to use a sawtooth voltage, which is generated by an LFO. This sawtooth voltage is seen here in yellow on the oscilloscope. And accordingly, it is also fed by a yellow cable into the XN jack of the module. This sawtooth voltage is synchronized with the loop of the melody. This means each point in time of the loop is assigned a unique, repeating value of the sawtooth voltage. One could also imagine this as a two-dimensional coordinate system, in which a cursor on the x-axis always travels from left to right, representing the current point in time. While in blue, the pitch is plotted on the y-axis. So now we made sure all required information is available to the network. The network continuously produces an output signal, which is supposed to reproduce what the network has learned so far. This output is available as a control voltage on the Y-out jack. In our example, this is the orange cable. Accordingly, this output voltage is visible in orange on the oscilloscope too. Right now the module is in freeze mode. The freeze switch is flipped down, so no learning is happening at this moment, and the network was reset. This means it has not learned anything yet, and the output line is completely flat. Let's listen to the input melody for a moment before we start. This is the melody the net is supposed to learn. Let's turn it off again and turn on the network's output. Since the net hasn't learned anything yet, the pitch is just one constant value. Next, I will switch off the freeze function so we can witness how the network begins to learn the melody. We see that the pitch starts to jitter up and down. The network tries to approximate the given input values. Using the two potentiometers, alpha and beta, it is possible to influence the learning behavior of the network. The parameter alpha is more related to the learning behavior of each individual neuron, while the beta knob controls a value that is relevant for the entire network. The technical documentation of the module explains in more detail how to understand these parameters. In order to increase the learning speed a little, we turn both knobs to the right. This means improving the network's capacity, and already, a significantly better learning success is achieved. Now the network is much better able to reproduce the shape of the control voltage. At the very bottom of the module, there are two elements that deal with the error of the network, the output jack and the LED both represent the momentary degree of error. Let's put this value on the oscilloscope too, as a green line. At the respective point in time, one can estimate how incorrect the network is currently calculating. For the purpose of demonstration, I will press the reset button, returning the network to an initialized state so that we can see how the error level reduces over time. So it's possible to control other modules, maybe filters or effect modules, depending on how wrong the network currently is. Resetting the network can always be performed manually with this restart button, or by sending a trigger signal into the respective input jack. Using the freeze switch, it is possible to pause learning. Then the network continues to operate, and the output voltage is continuously calculated. But no more learning takes place. You will observe that the orange line is now much smoother in freeze mode, because the network now only responds to the input data, but there is no learning self-correction anymore. If I turn this function back off, I allow the network to learn again, and then you can see the fluctuations return, which are caused by the learning process. The output control voltage can be used, as in our case, to control a VCO and make the network sing along with the melody. Instead, it is, of course, also possible to use this control voltage for other things. For example, to control filters, effects, envelopes, or whatever comes to your mind. It goes without saying that the output signal can be manipulated by additional modules in order to reshape it for other purposes. Many of these things will also be time-based, like this melody. So the pattern of having a time-based signal on X, like the sawtooth, and some other signal on Y, will repeat often. But, of course, it is also possible to work with completely different signals which are not necessarily time-based, but are connected with each other in some other relationship, which is more or less obvious to us. Our brain module makes it possible to explore such relationships too. We hope it will contribute to the diversity of the Eurorack universe. Have fun experimenting with machine learning and AI on a very low level. You can find much more information about the BRAIN module and our other products on our website.